Hi, everybody. Today I want to talk about something that your students might be seeing in one of their sheets at home. It's called prime factorization or factor trees. And basically what we're looking for in that is looking for prime numbers, which are numbers that can only go into one in itself. So for example, 5 is a prime number because you can only do 1 times 5, and 1 and 5 are the only factors. Composite numbers are the other numbers. So for example, 8 has factors of 1 and 2 and 4 and 8. You can multiply by a couple of different ways to get 8. So that is considered a composite number. So one of the sheets that you may have seen at home has problems looking like this. So we're going to go through the first one first. And as it says on the directions, the circles are the prime numbers and the squares are the composite numbers. So normally when we do factor trees, we can look for any way to factor 44. So you could do 2 times 22. You could do 11 times 4. And 1 and 44 are also factors of 44. However, when we're making factor trees, 1 is never going to be any of the numbers that we put down below because it doesn't get you anywhere, because you're still left with 44 if you did 1 times 44. So we're not going to use 1 as any of our factors. So we're looking for a prime number here. And so we've thought about, okay, we can do 4 times 11. So 11 could be our prime number. Or, because this is an even number, we could do 2. And 2 times 22 would give us 44. And 2 is also a prime number. So I can choose either of those options. I'm going to choose 2. And then the composite number that we multiplied by was 22. Then I'm going to factor 22 now. And so I see that I'm looking for 2 prime numbers. And other than 1 times 22, and again, we're not going to use 1 because that doesn't get us anywhere because we still have 22 again. And so the other way to get 22 is 2 because 22 is even, and 11. And I know that 2 and 11 are prime numbers because the only way you can get it is 1 times its number. So 1 times 2 is 2, 1 times 11 is 11. And then, so now we have all the prime factors of 44, and that is what prime factorization is looking for. And then below that, we can do our number sentence, which is 2 times 11 would give us 44, and we are left with all prime numbers, and our 2 and our 2 and our 11. Now, if your child wants to take it one step further, we can look at exponents, because I see that there is a number in here twice. So if I had 2 to the second power, that is the same as 2 times 2 times 11, which would be 44. Okay. Now another example up here is 90. And again, to get 90, there's lots of different ways. But the way that the problem is set up, I'm looking for a prime number and a composite number. Okay. So when I first look at 90, I think, ooh, 9 times 10. That is a way to get 90. However, that doesn't fit with what the problem is looking for. So then I think, oh, 90 ends in 0. So I know that a number that ends in 0, we can multiply by 10. But again, we talked about 9 times 10. Both of those are composite, so those aren't going to work here. 5, multiples of 5 end in 0. And so I can figure out what